you separated the sand by using the physical properties of the components of the sand. The physical properties. Now, recalling your experience when Batsheva helped us with the classification lesson, what is sand? Is sand a mixture or a pure substance? Which one is it? Please discuss that for a few seconds as I write this. Great. Thank you. Yes, sand, you're right, is a mixture because it has some things that you easily separated. You separated out things that were attractive to a magnet, and you separated out things that were soluble in water. So sand is a mixture, not a pure substance. That means sand contains several pure substances. Now, in this mixture, there were things which you separated, and you separated them using a magnet. So the word in chemistry and in physics for objects that are attractive to a magnet, that word is ferromagnetic. You separated that mixture by using a magnet. There's no need to write this down. I just want you to see these words, understand these words, be able to use them in discussion. But I don't want you to write. I don't want you to write them down unless you feel it is necessary for yourself. The other property that of the components of the sand mixture that you used was the solubility in water. Now, what I want you to understand here about physical properties is that a physical property is something that you can notice or observe without changing the substance that you're observing. So, for example, the property of being ferromagnetic. You used a magnet to separate some magnetic stuff out of the sand, and when you did that, you did not change that magnetic stuff. It was still magnetic. If you were to mix it back into the sand, well, the sand would just go back to looking the way it had looked before. Remember, for most of you, the ferromagnetic stuff was black in color. Get some black here. So the ferromagnetic stuff was a bunch of black grains. If you mix that back into the sand, it takes the sand to its previous state before you had taken that magnet to the sand. Now, what about solubility in water? Get some blue here. So with solubility in water, there was salt in the sand, obviously, because the sand came from Santa Monica Beach. There were other things that are soluble in water that were in the sand. When you take salt out of water, let's say these dots are salt. Suppose you were to taste that. You should never taste anything in a chemistry experiment, but suppose you had someone taste that salt. That would still taste salty, wouldn't it? When the salt is inside the salt water, you taste that salt water. It's still salty, isn't it? So the salt itself has not changed. It is still salty. If you remove the salt from the water, it is salt. If you put the salt back into the water, it is still salt. You can easily take the salt out of the water by boiling away the water. You can easily put the salt back into the water by just stirring, mixing and stirring. So solubility in water and ferromagnetism are both physical properties. They are things that you observe about something, about some matter, which don't change the matter just because you've observed that. Okay, those are physical properties. Physical properties are closely related to physical changes. Now, when you have some matter, let's say it is water in a beaker, you can change this. How can you change this? What if you were to apply a flame to the bottom of this beaker? You could boil that water away. When you boil the water away, this steam is still H2O, isn't it? Suppose you were to take that water and you were to put it in the freezer, and it would just freeze solid. So this is ice now, right? But the ice is still H2O. So boiling, freezing, these are all physical changes. You did a physical change to the sand in this experiment. You separated the components of the mixture. You moved things around. Those are physical changes. If you break a piece of ice in half, like that, or like that, if you break this in half, that is a physical change. Suppose you take some salt, and then you apply a hammer to it, and you smash it into smaller crystals of salt. This is a physical change. You have not changed the salt. If I were to taste your tiny crystals of salt, they would still be salty. It is still salt. Suppose you take those tiny crystals of salt and you dissolve that in some water right there. Remember, the solubility in water is a physical property. When you put the salt in the water, you're applying a physical change. You're mixing it with water. You've created a mixture. It is a homogeneous mixture. It is a solution, but it is still a mixture, and the salt is still salt. There's the salt. There's the water. That salt is still salt. This is a physical change. It is not some new thing in that water. It is salt. And it is easy to remove the water if you just heat that water up by applying some flames to the bottom or something. If you remove the water so the water is all gone, the salt will remain by itself. So these are physical changes. Physical changes are usually easily reversible. There are other changes which are not physical changes that are also reversible, but a clue that a change that you have done is a physical change rather than some other kind of change is that the change is easily reversible.